Hi, so this is a quick overview of the svelte-api-keys project and what it's useful for, why you might want to use it. So if you have a public API, anything that you want to provide programmatic access to, normally that means another piece of code is going to call it, not an actual user. So they're not going to authenticate in the normal user interactive way. So typically you provide a key, a token that they can use to make calls. And this is so you can put limits on how many calls they make, and you can also apply permissions to limit what they can do. So let's just start by creating a key. So typically give it a name and description just so you know what it's used for, what you're going to use the key for. And good practice is to set an expiry date. And we'll say that this key can just read. So these are the only permissions I can set for this system. In reality, you could set whatever permissions you want to use within your app. So if you think about something like GitHub, they have permissions like, can you list repositories? Can you, iterate commits? Can you make a commit? Things like that. So we'll create a key. Now, an important thing that this does is it generates the key once, and it sends that to the user. So you only display it once. They get to make a copy of it and store it somewhere securely. But you don't actually use that key within the system. You don't store it anywhere. Everything is done via a hash of that key. And this makes things more secure, because no one can ever, if they got access to your database either through a hack or a user maliciously exposing information, they can't give away customers' keys. So no one can ever make requests on behalf of someone else unless they leak the key. So let's use that key, and just to show you, I can make a request, and that succeeded, got 200 response. If I try a put, which would equate to a write in this example, that gets denied. So great. And if I don't include a key, it tells me it's missing. If I put a wrong key in, it tells me it's invalid. So that's the basic working. Let's create a let's create an expired key. So we'll put that in the past. We'll give it all the permissions. We'll create the key, and we'll use that one. And for this example, by the way, this key is just being stored here in local storage. But normally you'd use the information that comes back. For example, you could search by the user. I'm using just an email for this example. In reality, this would probably be behind some auth system, so you'd use like a user ID or whatever. But anyway, so I'm using this expired key, and now I can't get or put, even though it's got those permissions, because the key's expired. So that's good practice. And of course, you could have a live system. You don't have to put an expiry if you don't want. And the security for this would work the other way. So this can't do a get request, but it can do a put request. And then the other thing that you can do with this is you can limit the requests. So we can do 10 at once. Now notice this last one had a reset of 2. If I do 10 now, it's now delaying the request. So that's because we're also rate limiting based on the user identified as part of the key. So not the key itself. It's important, especially if you allow self-service to create keys, because otherwise people would just create new keys and get around the limit. So you're limiting based on the account. So they can create whatever keys are useful for them and limit what each key can do, but you can still rate limit based on the user as a whole. Now, just to show what the rate limiting does, this uses what's called a token bucket algorithm, So basically, if you have a bucket that refills at a constant rate and it has a capacity, and if there's a token available in the bucket, then you can make a request. And normally you just can consuming one token. So you say, oh, I consume one when I make a request, and then the bucket fills up. Now you can change the rate. So this is where you say, 30 requests a second, however many an hour, a week, a day, whatever you want the limit to be. And that comes down to your usage tier that you'll provide in that account. Now, as you consume all the tokens in the bucket, when you make requests at that point, it will be responding with a 429 response to say too many requests. But it includes the time that the client should wait before it makes the next request. Now, obviously, the rate that it refills will change the frequency that those requests can be made at. And the other part of this is you don't need to only make, if you want to limit things, say you have an API, you want to limit the number of requests that can be made, but not all requests are equal. Some are consuming more resources than others. What you can do is you can have a cost to a request, so you can make 10 requests that each cost 1 token each, and it will do those one every second. But that's different to saying one request that's 10 tokens. If we just let these others run out, you see when I consume this one, so when it gets to the 10, instead of it running the same of once every second, what will happen, let's speed this up, I got trigger happy. So what will happen now is it has to wait until there's 10 tokens in the bucket before it can fulfill that one request. But you can still make single requests in the meantime. So this is having one limit shared between different APIs, but having a different cost to those APIs. So say, for instance, fetching a list of comments made against an image could be considered a cheap operation, whereas generating a new image using AI might be a heavy operation that consumes more tokens. But you can still separate this. So you could, if you want, say, well, that API endpoint gets a completely different set of rate limiting parameters. So that's what the system does. It lets you create keys, put permissions and expiry dates on keys, let people self-manage, or provides the information if you did want to have a self-management portal, or you can be generating the keys for them. It stores them securely internally so that you're never exposing the keys, you're only ever working off a hash. And it provides the rate limiting and all the headers that come back from a response have all the rate limiting HTTP headers so that the client can back off. But even if you can't guarantee that the client's going to be well behaved, and if they're not, you can at least be batting those requests away. And the rate limiting, the idea of the token size, the bucket size, and the refill rate, that gives you a bit of kind of burst capacity. So what you're aiming for is that legitimate users never hit a limit. You're only impacting if they've got some faulty code that's doing the wrong thing, or they're kind of just trying to consume too much. So that's it. Let me know what you think. Cheers.